Today we're going to look at solving using the quadratic formula. And first we need to recognize that all quadratic equations of this form, ax squared plus bx plus c equals 0, which is standard form, can be solved by the quadratic formula. In the previous example, you heard the quadratic formula song, and that's just a mnemonic device to help you remember what goes where and what it is. But here we have x equal to minus b, or the opposite of the b value, plus or minus the square root of b squared, the b value squared, minus 4 times the a value times the c value. And then all of that, the minus b, the square root, all of that divided by 2 times the a value. And so what we're going to do now is we're going to use this quadratic formula to solve a quadratic equation. And so we have a quadratic equation here, and it's not in the ax squared plus bx plus c form, so we have to do that. And in order to do that, we basically just solve for 0, or set it equal to 0. And by setting it equal to 0, what we really are saying is we need to make sure that we have all of our terms on one side. And so we have 2x squared plus 3x minus 5 is equal to 0. Our very next step, after we make sure it's in standard form, is to label our a, our b, and our c so that we know what we're using when we use the quadratic formula. So a in this case is positive 2, b in this case is positive 3, and c is minus 5. And we have to remember that our quadratic formula is x equals the opposite of the b value plus or minus the square of the root of b squared minus 4 times the a value times the c value divided by 2 times the a value. Notice that my division symbol or my fraction bar covers the entire numerator. And don't get lazy and only put it under one piece or the next. It's a common mistake with students, and they tend to forget that it covers everything. So I'm now basically going to do what I do with every formula. I take the numbers and I plug in, and then I evaluate the formula. So I have x, which is what I'm solving for. The plus or minus reminds me that I'm going to get 2 answers. And the opposite of b, well, the opposite of b is minus 3. I'm going to have plus or minus the square root of whatever b was, which was 3. Square root of whatever b squared minus 4 times the a value, which was 2, times the c value, which was minus 5. I'm going to make sure I use my fraction bar for everything and divide all of that by 2 times the a value. Now I'm going to use what I learned in chapter 10, and I'm going to simplify. So I have x, which is what I'm solving for, the opposite of b, plus or minus, and now I have to do what's inside the square root. And so I get 9, and then I have a minus, and times a minus, which is a plus. 4 times 5 is 20, times 2 is 40. All of that's going to be divided by 2. And so what I end up with is x equals minus 3 plus or minus, well, 9 plus 40 is 49. And the square root of 49 is 7, so I get not the minus 3 plus or minus 7, all divided by 4. Since I can actually combine these terms, I get minus 3 plus 7 divided by 4. And, or minus 3 minus 7 divided by 4. And in this case, I'm going to end up with 2 answers, as I always end up with either 2 unique solutions, 1 unique solution, or no real solutions. And in this case, I'm going to have a minus 3 plus 7 is a positive 4, divided by 4 is 1. So I get x equals 1, or x equal to minus 3 and minus 7 gives you minus 10, divided by positive 4. And that's going to give me minus 5 over 2. And so I get x is equal to minus 5 over 2. That's legal. You can leave it that way, but you should know that that's negative 2.5. And I also get, at a different place where this function is going to be equal to 0, because remember, I'm solving and getting what the values of x are that makes the function 0. So I get x equals 1 and x equals minus 5 over 2. In our next example, we're doing the same exact thing, and it doesn't matter which side we put our numbers. as long as we make sure that our entire equation is equal to 0. So just to show you what that looks like, I'm actually going to move things to this side, to the left, by doing the inverse on both sides, remembering what's a like term and what's not a like term. So I get 0 is equal to minus 3x squared plus x plus 12. This is not something I would do if I was solving. If I was solving, I would want to get my leading coefficient or the a value to be positive, but I'm not factoring when I'm solving. In this case, I'm using the quadratic formula. So my a value is minus 3, my b value is positive 1, my c value is positive 12. Again, I have to make sure I put it in standard form first. My formula is x equals the opposite of b plus or minus the square root b squared minus 4ac, the entire portion divided by 2 times the a value. So now with any formula I plug in, so I get the opposite of b, which is minus 1, plus or minus the square root of b squared, well, b squared is just 1, minus 4 times the a value, which is minus 3, times the c value, which is positive 12. And I'm going to divide that all by 2 times the a value. And so I get x is equal to the opposite of b plus or minus, well, I get a couple of things. I have 1 minus, well, this minus times the other minus gives me a positive 1 plus 12, because 4 times 3 is 12, and that 12 times 12 is 144, all divided by minus 6. And so I get x is equal to minus 1 plus or minus the square root of 145 divided by minus 6. And so I want to check to make sure that there aren't any perfect squares that go into 145. And since 25 doesn't go into it, which is a perfect square, 1 is an unusable, this ends up being my answer. I get 2 answers. I have minus 1 plus the square root of 145 divided by negative 6. And I get minus 1 minus the square root of 145 divided by negative 6. So this is my answer. In the last one, we're given a problem which is automatically in standard form, which is good for us because it doesn't mean we don't have to rearrange anything. We're going to identify our a, our b, and our c. Our a value is positive 2, our b value is minus 8, and our c value is positive 3. Using our formula, which is x equals the opposite of b plus or minus the square root b squared minus 4ac divided by 2 times the a value. So again, it's a formula we plug in and evaluate the formula. So I have minus b, or the opposite of b, which is going to give me a positive 8, because the b is negative 8, plus or minus the square root of minus b squared, or minus 8 squared, minus 4 times positive 2 times 3. All that's going to be divided by 2 times 2. So I have x equals the opposite of b plus or minus, well, I have 64 because I get minus 8 squared, minus 2 times 4 is 8, times 3 is 32, all divided by 4. And so what I end up with is I have x is equal to 8 plus or minus the square root of 32 divided by 4. I'm going to get the exact answer for this problem. And the way I'm going to do that is I'm going to take 8 plus or minus. Since there's a perfect square of 4 that goes into 32, I'm going to split it up into 4 and 8. Hopefully you recognize that 4 isn't actually the biggest perfect square that goes in there, but I'm going to use that anyways to show you that you can still do it. And so it's just going to take a little bit longer because I have more steps. I'm going to have 8 plus or minus 2 square root of 8, which I can't combine with the 8 in the front. The 2 square root of 8 and the 8 are not like terms. And so what I'm going to do is I'm going to continue to go because I should recognize that the 8 also have a perfect square of 4 in it. So I'm going to have 8 plus or minus 2 square root of 4 times the square root of 2 divided by 4. And again, because I didn't pick the largest perfect square, I have more steps that I must do. So I have 8 plus or minus 2 times the square root of 2, all divided by 4. So I get x is equal to 8 plus or minus 4 square root of 2 divided by 4. The next and last step I have to recognize is that if I have a binomial in the numerator, which I have a 8 and a 4 square root of 2, and that I have something that I can factor out of that that's in common with the bottom, I should do that because that will make the answer the most simplified it could be. And so what that means is, well, I have a factor of 4 that's in the second part of my answer in the numerator, and I have a factor of 4 in the first part, so I can factor out a 4. That's the greatest common factor, the GCF. When I factor out 4 out of 8, I get 2 left. The plus or minus stays. And when I factor out 4 out of 4 square root of 2, I only get the square root of 2 left over. That's all divided by 4. And if I look carefully, I'll see that I have 4 on top that's being multiplied and 4 on the bottom that's being divided. Those 4s are actually able to cancel. And so my final answer that's completely simplified is going to give me 2 plus or minus, which gives me 2 answers, 2 plus or minus the square root of 2. That would be my exact answer because I'm left with an irrational number. If I wanted to find the approximate answer, I would have to do both parts. So that means I would get 2 plus the square root of 2, and that's going to give me x equals 3.4. And if I wanted to round to 2 decimal places, it would be 3.41. That would be the 2 plus the square root of 2. So this one is the approximate answer of the exact answer, which is 2 plus the square root of 2. And then I have x would be equal to 2 minus the square root of 2. And that would give me the approximate answer of 0. And if I round to 2 decimal places, 0.59. And that would be the approximate answer that goes along with the actual exact answer of 2 minus the square root of 2. And so I would have this answer, approximate in blue and exact in red, or this answer, approximate circled in black, approximate circled in red, and the exact circled in black.